Okay, this is homework 5, the physics problem, number 5.82 from the physics book. Here is an overhead view of the figure. It has 5 forces pulling on it. All of them are defined here. All the angles need to be taken off of the x-axis when I put this into vector notation. And they want to find the box's acceleration in unit vector notation and the magnitude of the acceleration and then the relative angle to the x-axis. So let's get going on that. Okay, the first thing we want to do is we want to put in our basic constants that we need for this, which I'm going to do here. Well, the first thing we want to do is we want to do in the physics format that Dr. R likes, and that is our given, which is right here stated, what we're going to find, okay, in each case, okay. Figure, we can't do that. I've got this hanging out here to the right so that we can look at it and reference it. A plan is to use the fundamental equations, vector notation, and addition principles for A and B, and use trigonometry for C. The assumptions, the x-axis will be used for all of the vectors, okay? And then an estimate, okay? Convert all forces to vectors, add the vectors from the figure. Final force should be a small, okay, when I'm looking at this. I think it should be small and down to the right a little bit, okay? If I added all these together, if I put 3 on here, 5, 1, and then 4, I think I'd be right about here, okay? But I could be wrong. It could be in the first quadrant. It's either in the first or fourth. We'll see. Okay. So I start out, mass is, of course, we know F equals ma, okay? And the mass is 4 kilograms. Each one of these is the forces as defined right here. F1, 2, 3, 4, 5, and so on. I'm going to display the acceleration vector as a vector by adding F1 through 5 and dividing it by the mass. Acceleration equals force divided by mass, okay? In the second problem, I'm going to display the acceleration magnitude, okay? And I did my standard magnitude acceleration, square root of the dot of ACC, okay? And in the last case, I want to find the angle, and that's going to be the y value over the x value, okay? A tangent D. And we'll go ahead and run this and see what happens. Okay, and so I get 1.03 in the I direction, minus 1.25, so it was in the fourth quadrant, in the J direction. The magnitude was 1.62 meters per second squared. I should have added that in there. And the angle of the acceleration with respect to x-axis is minus 50.482 degrees. I hope this helps everybody.